Oikein väli. Jaha. Okay, this time I think it's time to move on to the next flight numbers besides of mass, so the actual flight numbers. We're gonna go over speed and glide. But before that, the recap of what we've already done. So first we talked about momentum. We kind of used the example of collisions, these small collisions between disks and various objects. We talked about acceleration and release speed, and we used Newton's second law. And I still have one more thing, really an important concept related to mass. Moment of inertia. And this is kind of a tricky one. Formula for it is mass times radius to the power of 2. Doesn't really apply for a disk, but it applies for a idealized pointy object. But it's one formula for moment of inertia. It is something that is related to turn and fade. And more broadly, it's something that is related to gyroscopic effects. You need an object that is rotating. Okay, so this yo-yo is made of aluminium, I think. And I think it has relatively high moment of inertia. So what I mean by that is if it rotates, it can hold this plane of rotation pretty well. It is stable object. If it's not rotating, of course it's not holding anything. That is what moment of inertia is all about. I can also demonstrate turn and fade with this yo-yo. This yo-yo has a kind of specially made axle. So I can grab it, and as I jerk it, it starts to move unexpectedly. And this is what makes turn and fade and all these gyroscopic effects weird, because they aren't intuitive. Points of the yo-yo are moving in different directions, and you are applying forces on it, acceleration in directions which are happening all at the same time. It's one of the most difficult concepts related to motion. So this yo-yo has a special axle, and I attached another string to that axle. And of course, what happens when I release? It just hangs there, of course. It just hangs on the string. But what happens when the yo-yo is spinning? This is a little bit tricky, so let's see. Watch what happens. Yeah, so I kind of made it happen. So the axle was kind of hovering, but it starts to rotate that direction. And that is exactly what turn and fade is. Turn and fade is an effect that happens to a rotating object when you apply some torque. It's actually a combination of gravity and lift that is torquing the disc, and this causes turn and fade. People always say the disc goes to the right or disc goes to the left, but it's not really about that. If you want to be more precise, it's that the rotation axis is rotating either clockwise or counterclockwise when you watch it from behind. So it is quite complicated. We will talk about turn and fade more in later videos. Now we're going into actual flight numbers. So we start with speed and then glide. It turns out these numbers really aren't that well defined. They are very vague. So let's start by looking at what some manufacturers claim about the flight numbers. So let's start with the Innova. So speed is the rate at which a disk can travel through the air. Okay, that is interesting because this can travel through the air in all kinds of rates, I think. Faster disks cut into the wind with less effort and are best when throwing upwind. I guess they're saying faster disks are more aerodynamic or they have less drag. Slower disks take more power to throw upwind, but they're easier to throw more accurately and may actually go farther downwind. Interesting. High-speed discs are not recommended for beginners as they require more power to fly through to their ratings. A faster disc requires more power. That's one idea here. Okay, let's see what MVP has to say about the speed. Speed is an indicator of the amount of initial velocity necessary to achieve optimal flight of the disc. Really different idea to look at speed. Higher speed disc requires higher initial velocity or release velocity. There is no clear measure or a real property that's related to the speed of a disc. And I actually took some numbers out. First from Innova and then from MVP. My expectation was that there is actually a measure which is the rim width. So that's why I took the rim width of each disc from Innova. I was quite surprised actually that the rim width, it doesn't correlate exactly with the speed. So I put in speed and rim width, and as we can see, lots of different rim widths. For example, well, we can see it from the table. For example, in speed 12, we have Destroyer with a 2.2 centimeter rim width, but also a T-Devil with 2 millimeters thicker rim. And almost identical flight numbers, only Destroyer has slightly more fade. Then we have Boss with 2.5 centimeters, speed is 13, but then we have Colossus 2.5 and speed is 14. So quite a bit of variance in it. If we go over to MVP side, the rim width is in millimeters. As you can see, they correspond exactly to the speeds. 23 millimeters is 13, 21 millimeters is 11 speed, until Deflector. And Deflector has a higher rim width but the same speed as Vector. But it has less glide and more fade. The MVP is saying Deflector needs more speed to achieve that flight path. Do we have any other examples? Yes, we do. So we have the Vertex, and then we have Entropy, which is really weird because it's 10.5 millimeter rim width, but it's 4 the speed required to throw it. So I guess it's a really overstable. Is it the mid-range or putter? I don't really know. MVP is very consistent until you go to some of these discs where they're starting to go away from that idea, and I don't really like that because I think what is most important for the feel of a disc is the rim width, and that's what's important. I don't care about the speed number. I care about how much there is dome. I care about the rim width. I care about the wing height. These three things are the most important, like how the disc feels in my hand. It's a bit of a mess when you just have some kind of number. You don't really know what they mean. But okay, let's go over to glide. You would think it's more straightforward. A glided disc creates more lift, especially in low speeds. Glide describes the disc's ability to maintain loft during flight and is rated from 1 to 7. Discs with more glide are best for new players and for producing maximum distance. Beginners wanting more distance should choose discs with more glide. Discs with less glide are more accurate in high wind situations. MVP, glide is the measure of how well a disc retains loft in relation to the amount of power of the throw. Low speed discs with higher glide ratings are easier for new players to achieve longer flights. A disc with lower glide rating will be more resistant to wind, and players will be able to achieve more consistent lines in windy conditions. Yeah, I think that is kind of true. A disc with less glide is better in the wind. It's usually because it's flatter, it has less dome. It might even in some cases be faster. Flat disk is also quite often a disk that fades a lot. So yeah, if we look at the glide numbers of Innova, they just go all over the place. You have so many different glide numbers here. If we look at MVP, there is a little bit more pattern here. So every speed class, they usually start with something that has a stable disk with little glide. So here limit has only 3.5 and 5 and 5 and 5.5. Well, here it's not really the case. Energy is 4, 4, 5, 5.5, and then again 3.5, 5, 5, 5, 3.5, 5, 5, 5. So this is the kind of MVP formula. So the first disk is something that doesn't have glide, but it also has usually a lot of fade. So I think this is the problem. We have so many numbers and they kind of relate to the same thing. The stability of a disk is the most important factor. And that's what we're going in the next video. There's still some things. I did some graphs. First for Innova, the glide and speed. So we have glide. With Innova, it seems that there is a little bit of correlation. Innova gives higher glide numbers for faster disks. It kind of makes sense because when you have a driver, it is more aerodynamic. A driver can create more lift, at least in certain situations. Some drivers create a lot of lift, therefore more glide. Here's an R squared, which is a number between 0 and 1. And 0.3, it's not that big R squared. So high the number, more correlation. So it's kind of a weak correlation between glide and speed. But there is a correlation here. If we look at the glide and turn, here we have slight negative correlation. 0.2, that's actually, this isn't that significant, but it's something. So it seems that if we have a glide disk, it tends to be a bit more unstable. Which again makes kind of sense because when you have glide, you have acceleration upwards, and that can actually change the angle of attack, which then can create turn in some situations. With fade, really no correlation at all, 0.048. It's quite strange because turn and fade should correlate. Actually, we can see that over here, because usually a disk that has a lot of turn doesn't have too much fade. Yeah, this is kind of all over the place. So the correlation between turn and fade is quite weak actually with Innova. That is interesting. It seems like they are making these numbers up from their head. Okay, so let's go over to MVP side. The data is a bit similar here, but not enough disk really to say, and R squared is not that high. So if you have a lot of glide, then we have more turn. I think this is a real correlation here. So with MVP, disks that have a lot of glide also have quite a bit of turn. And you might think, why does this go downwards? Then it's because turn is a negative number. So smaller number here means actually more turn. And the fade goes into the same direction here. Well, not really, 0.077. Let's see if we have correlation with these numbers. Yeah, we actually do have correlation. So a disk that has a lot of fade doesn't have so much turn. That is how it should be, I guess. If glide and turn have correlation, and turn and fade have correlation, why doesn't glide and fade have correlation then? I calculated some parameter, which is so glide divided by ring width. The idea was that if we have little glide, the speed could be high even if the ring width is small. If we have a small number here then we could still have a high number over here. So T-Bird has quite a high glide compared to the rim width, but then kind of average speed. So I don't know if there's anything to do, but at least this is what I tried to do. And yeah, we have small correlation, but it's really, really small, 0.162. And it seems that slower discs tend to have more glide compared to rim width than faster discs. It's the, yeah, didn't really find anything interesting there. I tried to do it, but